हेलो एवरीवन, वेलकम बैक टू दिस वीडियो। आज की इस वीडियो में हम डिस्कस करने वाले हैं के मीन क्लस्टरिंग एल्गोरिथम और के नियरेस्ट नेटवर्क। दोनों ही एल्गोरिथम डाटा साइंस और मशीन लर्निंग का इम्पोर्टेंट टॉपिक है। तो चलिए स्टार्ट करते हैं के मीन क्लस्टरिंग से। के मीन क्लस्टरिंग इज अ अनसुपरवाइज्ड मशीन लर्निंग एल्गोरिथम यूज्ड टू ग्रुप डाटा into k clusters based on similarity. Each cluster is represented by its centroid, the average position of all points in the cluster. सबसे पहले के मीन्स क्लस्टरिंग एक अनसुपरवाइज्ड लर्निंग एल्गोरिथम है जिसका मेन एम होता है डाटा को के क्लस्टर में डिवाइड करना. So goal of K means to divide into K groups such that point inside a cluster are similar. Points from different cluster are different. Each cluster has a center point. एक क्लस्टर के अंदर के पॉइंट सिमिलर होते हैं और अलग क्लस्टर के पॉइंट डिफरेंट होते हैं. हर क्लस्टर का एक सेंट्रॉइड होता है. So how K means work? Step first, choose K. Decide how many cluster you want. पहले डिसाइड करते हैं कि कितने क्लस्टर चाहिए. एग्जांपल 3, we want 3 cluster. Second, select initial centroid. Pick k random points from the dataset as the starting centroid. ये स्टेप इम्पोर्टेंट है. स्टार्टिंग में हम रैंडम के पॉइंट्स को सेंट्रॉइड में मानते हैं, जैसे C1, C2, C3. Step, assign point to nearest centroid. For every data point, compute distance for each centroid. Assign the point to the cluster whose centroid is closest. This forms temporary cluster. हर डाटा पॉइंट का डिस्टेंस कैलकुलेट करते हैं सेंट्रॉइड से. पॉइंट जिसके सबसे करीब होगा उसी क्लस्टर में असाइन करते हैं. Recalculate new centroid. Once all points are assigned for each cluster, compute the mean of all points. The new mean become the new centroid, so centroid will move. हर डाटा पॉइंट का डिस्टेंस कैलकुलेट करते हैं सेंट्रॉइड से. देन इसके बाद क्लस्टर के बनने के बाद हर क्लस्टर का मीन निकालते हैं. ये मीन ही न्यू सेंट्रॉइड बन जाते हैं. Step 5, reassign points. Using the new centroid, assign every point to the nearest centroid. So नए सेंट्रॉइड के बेसिस पर फिर से पॉइंट असाइन होते हैं. Repeat step 4 and 5. Continue recalculating centroid and reassigning points until cluster assign stop changing, centroid stop moving, maximum iteration reach. This is called कन्वर्जेंस. सो प्रोसेस तब तक रिपीट होता है जब तक सेंट्रॉइड मूव होना बंद न कर दे. इसे हम कन्वर्जेंस कहते हैं. So final cluster, when the algorithm stabilize the cluster point or the final K cluster, the final centroid of each group represent the cluster. So फर्स्ट हम चूज करते हैं. सेकेंड, इनिशियल रैंडम सेंट्रॉइड. असाइन ईच डाटा पॉइंट टू नियरेस्ट सेंट्रॉइड. देन हम कंप्यूट न्यू सेंट्रॉइड ऑफ फॉर्मेट क्लस्टर. रिसाइन पॉइंट रिपीटेड until centroid stop changing. How initially centroid influence result. This is the one of the most important concept in K-means. But different initial centroid different cluster. Because K-mean start with random centroid, the final cluster can be different each time we run the algorithm. Risk of converging to a local optimal. K-means tries to minimize with the cluster distance, but if starting centroid are bad, the algorithm may end up poor clustering. So it may not find the best solution, only a local best. So convergence if centroid start for if initial centroid are poorly chosen. So algorithm may take more iteration, takes longer to stable, can be produce uneven cluster. Bad initial centroid may lead to one cluster having many points, another cluster having very few distorted boundaries that reduce clustering quality. Example of inference. The dataset has two natural groups. First case, good initial centroid to starting point and leads to. Second case, bad initial centroid both starting point fail inside the same natural group. K-means may split one group unnecessary and mix point incorrectly. How to reduce the problem to avoid bad result? Use k-mean initialization. Instead of random selected k-mean, select the first centroid randomly. Other centroid are chosen for a part that gives better, more stable cluster. Run k-means multiple times to final. K-means is a simple clustering algorithm that works repeatedly, assigning point to the nearest centroid and then updating centroid based on cluster mean. However, the choice of initial centroid affect the final cluster because the algorithm may converge to different solutions depending on where it starts. Poorly choose centroid may lead to slow convergence, incorrect cluster shapes, or poor clustering quality. Using technique like k-means help improve the reliability of result. Then अब next point हमारा k nearest network. KNN is a lazy instant-based supervised learning method. For classification, it assigns the class most common among the k nearest training example to query point. For regression, it predicts average. It does not training. It stores the training data and perform computation in predict time. सो ये एक सुपरवाइज्ड लर्निंग एल्गोरिथम है। जब हम एक न्यू पॉइंट को क्लास प्रेडिक्ट करना होता है तो हम देखते हैं कि उसके सबसे नियरेस्ट के नेटवर्क का क्लास क्या है। सो व्हेन टू यूज KNN small to medium dataset problems where the decision boundary is non-linear and you prefer a simple method. Good baseline for classification and regression. Work well when similar inputs have similar outputs. So algorithm step by step. Choose K, select a distance metric for each query point, compute the distance from the query to every point in the training set, sort the training point by distance, select the top K nearest network. For classification, count class among network. Choose the majority class. For use tie-breaking rules, optionally weighted network, return predict classes, then distance and metrics, Euclidean, Manhattan, Minkowski, cosine similarity, Hamming. Then choose soft K, small k, large K, higher wise, low wise. Typical practice, triode K for binary classification. Then हमारा weighting network, uniform weighted, each network votes equally, distance greatly reduce the effect of further effort. Pre-processing and practical considering. Feature scaling is essentially for distance method without scaling feature with the large range dominant distance. Handle categorical feature by using appropriate encoding and possibility difference distance missing value. In balanced class, KNN can be biased toward majority class. Use stratified sampling class weighted or small similar curve of dimensionality. In high dimension, distance become less meaningful. Consider dimension reduction, feature selection, or using appropriate distance. Computation cost. Then हमारा complexity, training time, prediction time, and memory. Evaluation metrics, accuracy, precision, recall. Choose based on the class, balance, and application. Use cross-validation to estimate generalization, performance, and pick KNN in text mining and sparse data. Represent document to TF, IDF vector cosine similarity is common because measure oriented instead of length, trial and tie breaking. If there is a tie in words, common rules, choose class of nearest neighbor among tied group, reduce K or randomly break ties consistence, use distance weighted voting to avoid ties, improvement and variant. Carry trees, build trees, faster nearest neighbor search, approximate nearest neighbor for very large high dimension data. Use matrix learning to improve performance. Use prototype reduce to reduce it. Work a numerical example digit by digit, Euclidean distance and classification. So ये हमारे data set query point choose K for Euclidean distance 3 distance formula compute each distance digit by digit distance compute distance for then distance B distance QC distance QD summary of sorted distance and classes. Then practical receive how to apply KNN well pre-process handle missing value in course categorical values scale choose matrix Euclidean for continuous numeric feature cosine for text is paired select K use cross validation plot validation error consider weighting if nearer neighbors should matter more use distance weighting acceleration for large and use KD tree, well tree, approximate nearest network. Evaluate use cross validation, confusion matrix, precision, advantage and disadvantages. Advantage simple and intuitive, no training time, naturally handle multi-class problem, non-parametric and can model complex decision boundaries. Disadvantage prediction can be slow for large dataset, memory intensive, performance degrades in high dimension, sensitive to or differently scaled feature and noise data and outlier. So use dimension reduction in future are many for text use. For imbalanced dataset, consider using different K or weighting or combined resampling methods. So thank you so much for watching. इस वीडियो में हमने बहुत ही इजी के मीन्स क्लस्टरिंग एंड KNN क्लासिफिकेशन दोनों के एल्गोरिथम को स्टेप बाय स्टेप एग्जांपल के साथ समझाया. So see you in next video.